So as I said, this log kind of like a power factor. In this case, it give you P. In this case, it give you S because it's VA. I'm about to tell you to analyze the question before you start. That's how I analyze my question. This fall into this V load. I like to analyze the question before I started, right? This piece here, they give me J, which is good. So therefore, that'll be 0.01, because if it's milli, it'll be 1, 2, 3. Yeah, plus 0.2J. So that will be my Z line. Let's analyze the question. V source, then give it, which is okay. I think that's all I need. All right, so let go. So I can draw my triangles. I might need space for this, so I'll go. This might take a little bit, but that's all it's a catch it, right? So let go back. Let me label it. I like to label it. So let me label this one A. I'll label this one B, right? Because it's two lows I give you, okay? If they give you two, you have to work it separately. So separate A and B. So let me just use a different color to differentiate it, right? All right, so there you go. So if you go back to the question, I need to know lag on top. So my angle should be positive, okay? Simple concepts. All right, so what they give me? They give me P, 50K. So 50K go in here. All right, what the power factor they give me? 0.7. So same equation, so we know power factor is the ratio of P and S. Yeah. So therefore, it was 0.7 is equal to 50K on S. So S would just equal to fling that across 50K divided by 0.7. Yeah. And that's what you get for that. So that is 50, 1, 2, 3 divided by 0.7. 50. All right, so that'll be 71.4 kVA. So that'll be S 71.4 K. Q, we have to calculate Q. So Q will be we didn't calculate the angle. Let's do that quickly. So cos inverse power factor is 0.7. So that'll be cos inverse as 0.7, which is 45.5, or say 45.6. Right, I'm not feeling to do two decimal places today. Right, so that'll be tan theta is equal to opposite. So the opposite adjacent. So tan 45.6 is equal to Q on 50K. Fling that across Q would have end up being 50K by tan 45.6. So that'll be 50, 1, 2, 3. Tan of 45.6, close brackets. And again, look at 51 kVAR. Nice. So we have everything. So like what I like to do, I like to write it in a complex form one time. So SA would that's equal to the real part, which is 50K plus 71. Oh, sorry. The Q 51K. Well, let's write it like this one time. Okay, I'd add it up anyway, so made no sense. So therefore, let's plug it in everything. So it that's end up being 71.4K is equal to 50K plus 51K. Right. If that confuse anybody, ST is equal to PT plus IQ. T. That is what I'm using, right? So that is what I get from A. So we have to do for B now. Nice. So let's go back to B and see what B is. So B leading. Seen bleed, seen lead, seen lead, leading, follow the leader, right? So lead, the angle we get is negative. They gave us S, right? So it's a different level, different kind of analysis how to go on here, right? So when you draw a triangle, I like to draw it underneath it, but after a while, you just know when you see lead, you know it negative. But for understanding purposes, for you all, I would draw it like this. You all could see what going on, right? So we know this is it here. So they gave us the S, which is here 100K. And what does they give us? What is it? They gave us the angle. So let's do this. So this is cos inverse 0.9, right? So cos inverse 0.9 is 25.84. But it leading, so we add a bit minus 25.84. Yeah? Yeah, let's be careful. All right. So we have what we do have. So let us draw a little thing. O H A. So we need to get P and we need to get Q. So let's do some tricks. So we have H or A, so that'll be cos minus 25.84 is equal to, so cos theta is equal to adjacent, which is P, and the hypotenuse. Fling that across, so P would is equal to 100K, like cos 25.4, 100, 1, 2, 3, like cos 1 minus 25.84. Alright, let's delete this. Oh, so it's 100, 1, 2, 3, cos, what else? Minus 25.84. Right, so I got 90K. So P is equal to 90K. Right, so we had to get Q. Alright, what trig ratio we could use for Q? So we have H, O, that is for sine. So sine minus 25.84. So opposite, which is Q, and the hypotenuse, which is 100K. Fling the 100K across, Q will equal to 100K sine minus 25.84. So 100, 1, 2, 3, sine minus 25.84. Right. So and then we get Q to be 43.5 kVAR. But, we know it's negative because it's going down. Yeah, that's why the Jody triangle, right? It's going down. So therefore, this here will be minus. Yeah, so let's be careful when you're doing it. Yeah, yeah, the big switch on when you're doing it. Because it's a leading power factor. If you draw the triangle like this, you expect Q going down. So Q expect Q to be negative. So just be careful when you're doing these things. It's not positive. If it was positive, it'll be going up. Like this one here. Yeah? But it's not this, it's this. It went down. So you gotta be careful. The A or P will always stay positive. No matter what. Yeah, okay, we're going in this direction. Whether leading or lagging. But the Q could be positive or negative depending on if it's leading or lagging. So let's be careful. So if I draw everything, I have everything, I have P. I just calculate Q. I have everything there, so I could just write it in like I write in the last one, right? So S B that's equal to 90K minus 43.5 I, and overall you have 100K is equal to 90K minus 43.5 I. Yeah, so that's how we do separately. So now we want to combine it together to get one power triangle because we don't want multiple power triangle, we want one. Yeah, so when you do one, you can just combine everything. So we call this ST. ST will equal to SA plus SB. QT will equal to QA plus QB. And PT will just equal to PA plus PB. Yeah, but you need to get the total before you calculate. So I do this, how we could do this in a way that, I mean, yeah, okay, let me tell you this. You don't need to add all these together. You can just add the magnitudes at the S one time, right? So let's do that part. So ST, remember, we need the angular. Let's do the figure that you need the angle. So ST will be SA The angle for SA is the power. The angle inside is 45.6 plus SP. So SP, the angle for SP was minus 25.84. Yeah. So this will just end up being SA as well. 71.4 K angle 45.6 plus SP, which was what? 100 K angle minus 25.84. All right, so you have to put in a calculator. So 71.4, actually 71,400 angle 45.6 plus 100, 123 angle minus 25.84. And I get 140 K angle 3.03. Yeah. So from here, we know that this piece here, but from doing this, just adding the S's from SA and SB, we can now get this triangle here, right? So obviously, and actually in your calculator, if you all know, you can actually switch from the phasor form. If I switch from the phasor form, I'll actually get what PT and QT is. So for me, it's just shift mode, complex, and 1, and I'll actually get what each piece is. So if I actually do that, ST, it just equal to 140.43 K plus 742, yeah, 7,427.39. I and that makes sense because when you add in the cube, you'll be 51 point K subtract 43. Yeah? So when you do that part, you'll actually get back what this is here. Yeah, it have two ways you can do it. You can actually just add up these pieces here and together. The reason why I do that is because if you just add up those, you wouldn't get what the angle is. But if you do it in phasor form, adding the S's together in phasor, you will actually get what the angle inside is, which is this. So it's actually better to do that way. So this is 140K, and the angle for this is 3.03. You actually get the angle for it one time, which you will need for the following part of the question to get IL, VL, and all that stuff. You need what the angle is. So my advice to you all is to work it in phasor. Keep it in phasor. Phasor at the default. Keep it in phasor. Yeah, just keep it in phasor. Complex form, they really help that much. I don't really see a question unless they gave you the answer. Like if you plug in Z, obviously Z had a plug-in complex, very real and imaginary. But when you're doing the questions, always keep it in phasor because they may ask you what the angle is and you had to know where it is. All right, it'll just be easier just to plug it in like that. Anyway, so let us go through. So we are S. We have what this is here, 7,427.39. We are, we know what PT is, let's say 140.43 K kilowatts. All right, so that's the overall power triangle. Yeah, so from there, we could, all the other steps that we did before will hold. Yeah, that's the good thing about it. So the first thing that want us to calculate was the total apparent power. We already get that. The total apparent power would be the total S, which was this here. Well, so this here, put the angle. It's this here. Yeah, we already calculated. Right, if you're confused, apparent power, apparent P, apparent power, the symbol for it is S, right? Real power, if you see, anytime you see real, the symbol for it is P, and quadruple, if I remember to spell that correctly, or that's reactive, it's just Q, right? I just don't know if it's quadruple. I don't remember all that, right? Like the English thing. Yeah, if I say the wrong thing, well, too bad. All right, so that is the trick. So if I hear them say, if I hear you say total apparent power, you had to know already that the total S. If I hear them say total real power, that the total P. If I hear them say total reactive or quadruple something power, it's Q. Just be careful. But it's the same steps I showed you all. Remember, I showed you all, right? They give you two loads. You hold the load separately. You can label it if you want to. A, B, work it down. Remember, I said with lead, the angle will be negative, right? And all the other steps will be the same. You calculate it, everything in parallel. Get it down to this piece here. Then you can add up everything. Add up the S's and phasor, and you get the angle one time. From there, you can get this. And if you want to get what the other part from this is, just in your calculator, you could switch from the phasor form to the complex form, and you will get what Q and P is one time. You don't need to go back and add the sum of the P and the sum of the. You could do that, but I mean, you already work the overall with the phasor. Yeah, so let me see if I could send you all a video at a, I don't know what type of calculator you all have. So let me send a video quick. I'll send it after. I don't want to take up time on the record. Right, if I didn't get it by like next hour, just message me. Alright, so there you go. So we at now. We just calculate the apparent, the line current. Okay. So we know the line current is the same equations like what we did before. Elegant change. So we know ST is equal to I conjugate by V. Yeah, there's the equation now. So we want I conjugate. So that will be equal to ST divided by V load. Alright, so what the V load in this case is for 400 hertz. 400 angle 0, right, guys? If they look at the angle, assume it to be 0. So remember I said this had to be in phasor. So you already calculate the angle and everything. So it'll be 140K angle 3.03 divided by V load, which is 400 angle 0. Yeah? So I go through. So when you do that in a calculator now, hopefully you can do it. 140, 123, shift angle 3.03 divided by 400 angle 0. All right, so let's just put that back into phasor form. So that'll be 350 angle 3.03, right? So this is I conjugate. So to get I, just find the conjugate of the conjugate, which is just where we want. So it could be the negative of the angle, right? So it could be negative 3.03 amps, right? So that I will IL. Part one done. Right. Part two, calculate the V source. But they try to catch you with this one. V source, they didn't ask you to calculate V line here. You see how they catch all here? So to calculate V source is the same equation, right? So V source will just equal to V line plus V load. The equation never changes. We have V load already, there's 400, right? But we don't have V line. Pressure in the camp, but we could get V line because we know equation. So V line is just equal to I line multiplied by Z line. So we know I line is 350 angle minus 3.03. Ready to get here, right? So Z line, that's the reason why let's just calculate Z one time. So there's 0.01 plus 0.02J, 0.2. Let me make sure 0.2. So 0.2J. Yeah. All right, so let's plug that in the calculator. So that'll be 350 shift angle minus 3.03. Oops. All right. Multiply by open bracket 0.01 plus 0.2 I close bracket equal. Right, so that is it. So that is 70.1 angle 84.1 volts. All right, so now we can actually calculate V sources. So V source, so that's equal to 70.1 angle 84.1 plus the V load is 400 at an angle of 0. So it'll be 70.1 angle 84.1 plus 400 angle 0. So it'll be 413.1 angle 9.71 volts. Right, that was VS. Alright, source for a factor. Let's go and write the equation. But the source for a factor is just cos theta V minus theta I. Alright, so in this case, it will be 9.71 subtract. Well, in this case, it will be 3.03. Just check my notes. I think that's what it is. Let me just check it to make sure. Where do I have my notes? Right, I have it here. Let's open it. All right, scroll, 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 scroll. Oh, I scrolled too much. Somewhere about, yeah, somewhere here. Right, yeah, so it will be, I was correct. So it's cos of, if I have to, should I break it? I'll break it down for you. So basically, this here is theta Vs. From here, subtract theta IL. Yeah, so that's breaking it down for you, right? So hopefully I'll catch it now. It's just VS, the angle that I was set to work it in phasor, right? Because once you work it in phasor, you'll be able to get where the angle is one time. So this will be cos theta VS is 9.71 minus 3.03. But that's what IL is, right? Hmm. So that'll be, so it'll be 0.975. That's the source power factor. Yeah, it'll just be cos of VS, which is this case here, which is this here, minus the theta IL, which is this. Yeah, that's where that come from. Just remember it. It's the same equation all the time. Yeah? Alright. So nice. So let go through. What the next thing I want us to get the sketchy phasor for the source line and load voltage. I'm not really feeling to do this. It's the same thing. So let go through. Remember I said the equation is VS is equal to V line plus V load, right? So we need VS. So VS was 413.1 angle 9.71, right? We need V line. What V line is? What V line is? Oh, get it. So it's 70.1 angle 84.1, right? And we need V load. V load was 400 at an angle of 0. So we have everything we need. So that's like I did before. Let's sketch it. So now V load. So you know V source is V line plus V load, right? Let's go. So normally I start with V load, right? Because that's the angle of 0. Alright, and number and then here. So the next piece is what 84. Oh, it's going up. Kind of start bad. This one going up. This one not going down. So I have to start low. I need more space. So this V load coming up here. And then V line now is 80 positive 84. So that one going up. So let me average where 84 could probably be right. It'll be V line. And as I said, you don't need to do the rest. So therefore, just connecting these two together, you get what V sources. And that makes sense, right? Because the angle was 9.71. Yeah, and everything add up it up. Obviously, when you're doing it, don't forget to write what each piece is, because so we'll take away marks. That's right what it is, right? Yeah, nice. As it is, same steps. Nothing has changed. Yeah. All right. So here it is. I think that you catch it by now. Right? It's the same things. When you send that changes, I have to give you two different loops, right? Just the calculate the capacity required for the load for the power factor correction to unity. I just gonna run three steps and I'm gonna do the maths. That's understand the concept, right? And that's the last question. So let us go through it. Oh, I run out of space. Oh no. Which part I could use right here, man? We could squeeze it in right here. So we have the whole. So we know this was 3.03. Let's go back and see what the rest. Man, we care about Q, huh? We don't really care about the rest. So the old Q was what was 4. It is 7427. 7427.4. 7427.4. 7427.4. PUR. Right, so really, we could put in the S, but we're gonna need the S to calculate the new one. So that really only is two things you really need, right? So this is QO, right? So the one that correct the power factor to unity. So the first thing we had to calculate is what the new angle will be, right? So cos inverse of 1, if I correct it to unity, if we plug cos inverse of 1, it'll be 0. So the angle is 0. It's crazy. All right, so therefore, basically, that's gonna be, yeah, because the angle is 0. The base is just remove, the base remove all this here. Yeah. So as I said, same steps. So let's erase that because it cannot be redundant and I need space. So you have Q capacitor, well, that's equal to Q old minus the Q new. Yeah, obviously the Q new will be 0, right? Because the angle is 0. It's on a vertical component. So that would be 7427.39 subtract 0, which would just be 74.2739. Yeah. So now we just need to calculate. Actually, we don't need to calculate anything. We just need to plug it into the equation. So I just skipping that whole derivation. So C would just equal to Q cap divided by 2 pi F. And remember, this is the load squared. That'll be Q cap is 7427.39. Very useful. Divided by 2 pi, what is it? F is in this question. I think it's 60. Yeah, 60. I'll probably crop the question part. But it's 60. Majority of the time is 60. Right? And I multiply that by below this 400 here. Squared. Let's see what the calculator will give us. So 7427.39. 2 multiplied by pi, multiplied by 60, multiplied by open bracket 400, close bracket squared, which should be redundant, but just anyway. So again, I put 123 microfarad. And that is the end of the question. Yeah, well, yeah. So one ChatGPT that I can't remember this right. Yeah, just remember one and just use it. Just copy and paste it for the questions asked. Oh, yeah. So that's easy. Yeah. But what it does do ideally is just reduce the reactive power in the circuit. That's as much I could tell. Yeah, that's why it is used. It reduces the reactive power in the circuit.